Now let us talk about the integration. Suppose we have to find out area under a given curve. Let me take first a straight line and I have to find out this area. Then it's not a very difficult task. We have a rectangle, we can see what is the value of x here, what is the value of y here. So this multiplied by this. So it will be y1 minus 0 and multiplied by x1 minus 0. So x1, y1. This will be the value of this area. If there is another shape, say for example we have a triangle formed by this line and the axis, then we can find out the area of this, or we can have even a trapezium. Then again, this is what we do in equations of motion. We can find out the area of this trapezium. But if we consider a slightly different curve, not just a straight line, say for example we have this curve and we have to find out this area, then this approach won't work. We cannot find out directly because it is not a triangle, rectangle or a trapezium. Then we need a slightly different approach. Y is a function of x here. X is independent and y is dependent variable. What we can do is we can divide this region into small rectangles. It will be like this. And I can find out the area of these rectangles. Let the width of each one be del x. And this will be different, y1, y2, for third it will be y3, then y4, then y5, like that. So I can write y1 del x plus y2 del x plus y3 del x, and so on. So this will be the area. But even now we will not get the precise value, the exact value of this area. Why? Now if we observe these rectangles precisely, this region is left. This is not being covered even when we are adding the areas of all these rectangles. So it means even this will not give me the exact value of this area. What can we do for that? For that, this del x should be very, very small. Because if it is very small, this area will be less. This should be almost 0. Then it will be just a straight line and this area will be almost 0. So there is a mathematical way to calculate this thing. I can write this now in the form of summation. So this is the area. Now we want that this del x value should be very, very close to 0. So how do we write it? We write it limit del x tends to 0 summation yi del x and I varies from 1 to n. This is how we will calculate this value. And we can have this approach here and we can find out the value of y as a function of x and then substitute here and find out this value. And eventually at the last step we can substitute del x as 0. We will get some value. But there is another way to write this. That is what we call as integration. So this can be written as this sign. We call this sign as integration and y dx. This is integration y dx. So integration means actually the summation of a product where one quantity is a function of other. It is a continuous variable depending on x. So y is a function of, I can even write it like this, and the value of x is varying, and those values of x from lowest value of x and the highest value of x we call limits of integration. Suppose x is a here and x is b here, then I will write here a to b. So integration is actually a summation, right, where we are adding the product of two quantities, one is the function of other. Now there are various, instead of going through this approach every time we have a problem of this type, we have direct expressions. We have expressions that can be used directly in integration. I am giving you a very common expression that we will be using. Other expressions, you can refer any book. We have a number of formulas. So if we have a constant x raised to the power n dx, then constant remains just like this as we have done in differentiation. X n dx is x n plus 1 upon n plus 1. This is how we solve it. And then there is a way to apply the limits. The minimum value of x is written here, the maximum value of x is written here. And when we apply these limits to this, first we substitute this value here for x minus then this value. Let us take one example. Say for example 3x square dx. So what it will be? 3x square, going by this formula, 2 plus 1 upon 2 plus 1. And if it is say 1 to 2, we will write here 1 to 2, and then 3 by 3. This is x cube. Now to apply these limits, first substitute the upper limit, so 2 raised to the power 3 minus then the lower limit, 1 raised to the power 3. So it is 8 minus 1, 7 will be the answer. So this is how we can use this particular expressions. I will share few more expressions. You can learn them and use them. Practice as much as you can. Once you practice these types of questions, then you will also understand where do we need this process of adding the quantities, or where do we need to apply integration as such.